Tonight what we are going to be learning about is scientific notation, and this really should be review for everybody in this class, but we are going to review it because it will be seen throughout the entire year. And we will be expecting you to be able to convert between standard, which is this type of notation, to scientific. Okay, scientific notation is in the general format of n times 10 to the x, or little sub n. And this would be the exponent, this little n, and this would be the number before the times 10. It is used often to express really large numbers or really small numbers in a tangible form that we can actually understand as human beings. Okay, so there's different steps that you do to solve for scientific notation. Just write these down. In this example, they do use z, but you can also use the little symbol of n. It's written both ways, so just get familiar with both of them, but it's a general format. So what you want to do is get practice converting from scientific notation to standard and from standard to scientific notation. So let's look at the examples on the right side right now. This is where you're going to be going from standard into scientific. So what you want to do for these is locate your decimal, which is after the 8 in this case. Calculate how many times you have to move that decimal over in order for the number before the decimal to be between the numbers 1 and 9. So in this case, you would have to get it to 5, because if I stopped after or in between the 6 and the 4, it would be 56, which is not in between 1 and 9. So my final number would be 5.643008 times 10 to the, and I moved it over 1, 2, 3, 4, 5, 6. So that would be to the positive 6th, which is basically saying times 10 to the 6th is the same thing as 1 million. So I'm saying 5.643008 times 1 million. It is saying the exact same thing. Now try to do the second one, the 78401. Once again, now I have the decimal right here between the 1 and the 2, which makes it 78,401 before the decimal, so I need to move it over 1, 2, 3, 4. So therefore, it would be 7.840126 times 10 to the 4th. You want this to be a positive 4 because I'm trying to make a number larger than the 7.84. Then we do the next one, which is 0.0327. So I'm going to move it in this case to the right 1, 2. So now it would be 3.27 times 10 to the, and I want to make it the number smaller than the 3.27 to make it 0.0327. So that would be a negative 2 because I moved it over twice. In this case, 1, 2, 3, 4. So it would be 5.298 times 10 to the negative 4th. That is how you convert between, that's supposed to be a 4, negative 4. That is how you convert between standard to scientific. Okay, so now we're going to go from scientific into standard. So if you copied all those steps down, all you need to do is it's basically saying in this first number that it's times 10 to the 6th, which is 1 million. So I need a number larger than 7.9 because I'm multiplying by 1 million. So in this case, I'm going to move the decimal over 6. So 7.9 moving over the decimal 6. So that'd be 1, 2, 3, 4, 5, 6. So every little loop I'm going to fill in a 0 that doesn't already have a number. Okay, so I end up with a number that looks like this in standard, and my commas to make it easy to see. So it's 7.9 million, which 7.9 times 1 million would be 7,900,000. Okay, trying the next one, all we're going to do is move it over 8, so that would be 5.498. So move it over 8 because of the exponent being 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we would end up with 1, 2, 3, 4, 5 zeros in that case. Okay, and no decimal right there. And then now we're going the opposite way for this one. So because it's a negative 3, I need to make a number smaller than 1, but I have to move it over to the left 3. So it'd be 1, 2, 3. So my decimal moving it over would be 0.0 0.0015. For the next one, I'm going to move it over 4. So it would be 1, 2, 3, 4. So I would have 0.000347. So that's how you convert between standard and scientific and standard. That should really be review. This is the new part, okay? I'm going to be teaching you how to use your E button. So I'm hoping you get your calculators. Go get your calculators now, put it on pause so that you can actually practice this. I do expect you to be able to do this tomorrow in class. So we are going to be teaching you about this lovely E button. On your calculator, it looks like an E button, but when you actually type it into your calculator, it shows up as like E, just one of them. So what you need to do is find that. This E button is so amazing because what it does is it actually takes the place of having to type in times 10 to the caret. So if you were to type in this number, you normally would have written it 7.5 times 10 caret 21. Well, instead now what you're going to do is type in 7.5 E21 because that E is the same thing as times 10 caret. What this allows you to do is prevent you from having to use parentheses, which a lot of times struggling students don't know when to use parentheses. They use them too much or too little. This E button prevents it because what it does is it says, hey, this number needs to stick together no matter what. You're not going to be timesing by anything, dividing by it. This number, no matter what, needs to stick together. So what you need to do is find your E button, okay? So you're going to find your E button depending on your calculator. You're going to have the E button above that 7 typically, okay? So what you're going to first need to do is press that second button and then that number above the 7 for both the graphing and just the scientific calculators. Okay, that'll show you up your E button. So everybody should practice that now to locate the E button and then clear your problem. Okay, so we're going to type in this number, the 7.5 times 10 to the 21st. So first how you do it is you enter the first portion of your number, which is 7.5. Okay, and instead of typing times 10 to the 21st, what you're going to do is you're going to find that EE button. So right now, find it, press that second, and then the number above that 7, and it should show up as this as of right now, typically on most calculators. Then we're going to type in 21. Okay, so you're going to type in 21, which is the exponent, and then you can press enter. If you press enter, you should actually see this exact number come out. Right? Let's do a practice problem. What's great about this practice problem right here at the bottom is that you're not going to need to use parentheses anymore around each of these numbers where you normally would have had to use parentheses. Because you are using that E button, you are no longer needing to use that. So everybody get out your calculator and start typing away as I tell you so you can become understanding of this E button. So we're going to do 6.2. Now I see that times 10 exponent. So instead of typing that, I'm going to type that E button and then 12. Okay? Then you're going to press divided by, because we will be dividing it, okay, by 9.6. Press that E button again, 23. Notice I never typed in times 10, E12. I didn't do times E12. I just did E12. Okay, you don't need to use any times. Do not use any tens. Do not use any carets anymore. And then when you press enter, what you should get is 6 point, and this is rounded, 6.458 times 10 to the negative 12. That should be a 12 right there. Should be a negative 12. If you did not get this, try it again. Make sure you just do those E buttons. But if you did it correctly, you should have gotten, once again, 6.458 times 10 to the negative 12. So now you know how to use scientific notation, go from standard to scientific, scientific to standard, and also use that E button, which we will expect you to use from now on. Thank you so much and have a great night.